5,000 light-years from Earth, a ghost drifts through the void of space. It has the shape of an hourglass, a bow tie, a butterfly, or perhaps a returning boomerang. But it is not a ghost. It is a dying star, shedding its outer layers in a spectacular display of cosmic violence. And it holds a record that makes it one of the strangest objects in the known universe. In the vast, cold emptiness of interstellar space, the Boomerang Nebula is colder than the void itself. This is a pre-planetary nebula, a brief and chaotic phase in the death of a star similar to our Sun.
At its center lies a stellar remnant, a white dwarf in its final stages, still pushing matter outward at incredible speeds.
Scientists measured it using a telescope that sees not in light, but in radio waves. The Atacama Large Millimeter What they found was astonishing. The gas in the Boomerang Nebula is at a temperature of just 1 degree above absolute zero. For decades, astronomers thought the Boomerang was just a simple planetary nebula. But two scientists, Sahai and Nyman, decided to look closer. They studied the light emitted by carbon monoxide molecules. But something was wrong. The light was distorted, absorbed by an invisible cold. The gas was absorbing the cosmic microwave background. That could only mean one thing. It was colder than the background radiation itself.
Sahai and Nyman calculated the temperature. Exactly 1 Kelvin. A record that still stands today.
For context, the background temperature of deep space is about 2.7 degrees above absolute zero. The Boomerang is colder than that. But how can an object in space be colder than space itself? This is where the story becomes a detective investigation. The answer lies in a process called adiabatic expansion. Imagine a gas that expands quickly into a larger volume. The molecules spread out, lose energy, and cool down. If you have ever used a pressurized can of air, you have felt this effect. The Boomerang Nebula is expanding so fast, at nearly 500,000 kilometers per hour, that it is literally freezing itself. As the gas expands into the vacuum, it pulls heat from its surroundings, creating a cosmic freezer colder than anything else we know. But even this explanation raises more questions. The expansion is too fast, and the cooling is too efficient. Astronomers have calculated that the star at the center must be losing its mass at an explosive rate to create such an extreme environment. ALMA's radio eyes cut through the dust, showing us the true shape of the nebula in unprecedented detail.
The outer regions are impossibly cold, while the inner lobes remain relatively warm. There is a temperature differential that does not fit the simple expansion model.
This measurement was so precise that it forced scientists to rethink the entire life cycle of dying stars. The molecule is the key. By tracing carbon monoxide, we can map the coldest gas in the universe. The evidence is incontrovertible. The Boomerang holds the absolute record for cold. But understanding why is a different challenge entirely. To cool this much space, the central star had to shed an enormous amount of material in a cosmic blink of an eye.
Since 1997, every follow-up observation has confirmed the initial finding. The Boomerang is consistently, unbelievably cold.
Nothing else in the observable universe comes close to this temperature. The Boomerang stands alone, a monument to extreme physics.
Some scientists now believe there may be a hidden companion star, a binary system where gravitational interaction is accelerating the loss of mass.
The Boomerang shape itself is a clue. The two lobes of gas are moving in opposite directions, creating a structure that looks like a bow tie or an hourglass. But the cooling we see in the Boomerang is far too extreme for the standard model. Something else must be driving this freeze. There is a thermal boundary within the nebula itself. The inner regions are warmer, while the outer shell is frozen to the bone.
This is not a permanent structure. The Boomerang is a transient phase. Within a few thousand years it will dissipate and warm up.
In a blink of a cosmic eye, This record-breaking cold will be lost to the void, mixing with warmer gas. The discovery was unexpected. Sahai later admitted they did not believe their own calculations at first. The central division of the lobes suggests an intense, focused ejection mechanism that we have not fully identified.
The physics is sound. Adiabatic expansion is the key. As gas expands,
The star at the heart of this nebula is in a superwind phase. It is shedding mass at a rate far beyond what a typical dying star can sustain. The gas is moving so fast that it has effectively turned the nebula into a cosmic refrigerator.
This absorption dip here clearly indicates the presence of methanol masers.
Yes, and the velocity gradient confirms the extreme outflow velocity we calculated.
The density profile tells the story. The core is dense and relatively warm. The outer shell is diffuse. To put this in perspective, liquid nitrogen boils at 77 Kelvin. The Boomerang is 77 times colder than that. The formula works, but the variables in this case are off the charts. The rate of expansion is so high that it pushes the limits of this equation. The star is not just dying. It is exploding slowly, leaking its entire atmosphere into the void. This phase is the final cry of a star before it becomes a white dwarf. It is a violent, beautiful, and ephemeral process. We understand the mechanics. But the deeper question remains. Why is this particular star so violent?
The companion star hypothesis is still unconfirmed. If it exists, it is hiding behind the thick dust.
Future instruments with even greater sensitivity will point back at the Boomerang. They will look for the faintest whispers of carbon monoxide.
Within a few thousand years, this record will be broken by time itself. The Boomerang will cease to exist as a distinct structure. Only the white dwarf will remain, a silent witness to the coldest place that once was.
We are still looking. We are still asking questions. The universe rarely gives up its secrets easily. Is the mass loss driven by a hidden binary? Or is this star simply a freak of nature?
The symmetry of the outflow is clear right here. Yeah.
But the extreme blue shift data suggests otherwise. It has to be a preplanetary stage.
The Boomerang Nebula leaves us with one clear, unresolved question. What is the true engine behind this cosmic freeze? The data is still incomplete. Astronomers are pointing their telescopes back, hoping to catch the faintest whispers of the coldest gas. Until they do, the record stands, but the explanation remains fluid. Some mysteries are solved, others are only beginning.